Okay, so in this video, we're going to start talking about how to find area of some two-dimensional. We're going to start with the rectangle and square because those are probably the ones that you learned in elementary, so you're a little more familiar with. Okay, first thing I'm going to do is give you the formula, and then we're going to talk a little bit about what everything means. So for rectangle, area equals L times W. Now, obviously A stands for area, okay? L stands for the length of the rectangle, and W stands for the width. Okay, now if I draw a rectangle, generally we say the length is the longer side and width is the shorter, but that really doesn't matter. Those two are extremely interchangeable. If you think about it, this is just multiplication, and with multiplication, you can switch the order around all you want. Quick reminder, I didn't draw that very well, but rectangles do have 90 degrees in all the corners, and that becomes important here in a couple minutes. And so that's basically how you find area of a rectangle. So for example, well, I'll do some examples in another video. If I say the length is 10 and the width is 5, we take 10 times 5, and our answer is 50, okay? We're going to talk about how to label here too. But we'll get to that later. So that's how you do a rectangle. A square, again, is just like a rectangle, but it has all four corners. A lot of people like to use area equals length times width times a square for a square. That's not completely wrong, but it's also not completely right. So yes, you could do area equals length times width. However, one thing about a square is if I use S for side length, all of the side lengths are the same. That's what makes it a square, not a rectangle, is that all four sides are the same. So if I were to plug that in, I would be taking side length times side length, and anything times itself is squared. So the actual formula for a square is area equals S squared, where S stands for a side length. Okay, so whatever the side length is, I can just take it to the second power, and that will give me the area of a square. Yes, it's the same thing as taking length times width. However, when you get into future classes and I give you the area and we have to solve for the side length, using this formula is going to be the much better one to use. So that's pretty simple. That's how you find area of a square and rectangle. Okay. Now, let's talk about a parallelogram. So parallelogram is a quadrilateral that's defined as it has two sets of parallel sides. So the sides opposite each other or parallel. We do not always have 90-degree corners like we do with a rectangle. A rectangle is actually a kind of parallelogram. It also has opposite sides that are parallel. It's just that it has all 90-degree angles. A parallelogram does not. Okay, and that becomes important here. So the area of a parallelogram, is BH, B times H, where B stands for the base and H stands for the height of the parallelogram. Okay, here is the most important thing that you have to know. Unlike squares and rectangles, what we use to find area is not necessarily the side lengths. Our height and base are not necessarily the side lengths of the shape. The height and base have to be perpendicular to each other. That is the symbol for perpendicular. And what that means is they have to make a 90-degree angle. So your height and your base have to make a 90-degree angle with each other. Okay, so for example, this is not going to be very good. Draw a better one. Okay. If that is my 90-degree angle, and this is not a very good drawing, and my base, this would be my base, this would be my height. Okay, those would be what I use to find the area. And notice how the height is not one of my side lengths. That 90-degree angle is what's needed. And I've always told students, think about when you go to the doctor and they take your height. They stand you up against a wall, okay, and you are standing straight and you are perpendicular with the ground. That's how you get a proper height. If you start to slant your body like this, that's not a good height. So we can't use slanted side lengths to get the height. Okay, so we do perpendicular, we come straight down, and we get that. Okay, so that's how you find the area of a parallelogram. In fact, that rule actually applies to rectangles. believe it or not, area for a rectangle originally was base times height, just like a parallelogram, except all of our sides were 90-degree angles. So we didn't have to worry about this other line there. So our height was always this and our base was always this. The sides automatically formed the 90-degree angles. And so we moved from height and base to length times width. But technically, this is also the area of a rectangle. It's the same concept. It's just that our sides are 90-degree angles, so we can use the sides. Okay, so that's a parallelogram. Now, when we talk about a triangle, okay, so you guys know a triangle is 3 sides. I'm a little better at drawing those. Our formula for area of a triangle is 1/2 base times height. So same thing, B and H stand for the base and height. Again, so that is true for a triangle, and so is this. Our height and base also have to make a 90-degree angle. Again, the height of the triangle is how tall is it straight up. This slanted side would be like slanting yourself at the doctor's office. You're not getting a proper height. Okay, it's not telling me how tall the triangle is. This distance straight up is what is telling me how tall the triangle is. So in this case, this is my height, and this is the base of my triangle. And so whatever numbers I would have there, I would plug into this formula, and that's how I'd get the answer. The biggest difference between these is you do have to take 1/2 times base times height with the triangle. Because if you think about it, a triangle, if I have a parallelogram, a triangle is half a parallelogram. That's why its area is half that of the parallelogram. Okay, so that's why it's like that. Now, a triangle, sometimes, if you have a right triangle, which means your side lengths form a right angle, this is your height and this is your base. So in this instance, we can have our side lengths be our height and base because our side lengths are making the 90-degree angle. Notice also, our base is not always the bottom side. So don't think base means bottom. Base and height are just 90 degrees. They form a 90-degree angle. Okay, the base is what's 90 degrees to your height. And in fact, these are interchangeable as well. I could call that the height and that the base. You're just looking for the 90-degree angle, and those are the 2 numbers that you would plug in. Sometimes with parallelograms and triangles, I'm not very good at drawing. You have a triangle like this, and sometimes you will see in books that they don't, it's too skinny to try and draw the height here. So what they'll do is they'll go off to the side, okay? And that will be your height. This is still your base over here. If they give you a distance here, do not add these together. This is your base, your height is over here. The reason they draw it over here is it's too skinny to try and fit inside the triangle. It's just like this. It's not gonna work. I can't physically draw it inside the triangle, so I just draw it off to the side. That is a possibility of what you will see, okay? Okay, now, our last shape we're gonna talk about is the trapezoid. A trapezoid is defined as having 1 set of parallel sides, not 2. So parallelogram and rectangles and squares are types of trapezoids. They're just extremely specific. Okay, so a trapezoid looks like this, where these 2 sides are parallel to each other. Okay, now what's different about a trapezoid than the triangle and the parallelogram is it has 2 bases. And so what we're gonna do is call this base 1, and we're gonna call this base 2. The height would be somewhere in there, okay? So area of a trapezoid is 1/2 times the height, parentheses, base 1 plus base 2. So remember your order of operations. They want you to add the bases together first because you have to do parentheses first. Then you would have 1/2 times the height times the sum of the bases. Okay, so again, base 1, B1 just means base 1. B2 just means base 2. And H means height, just like it did before. And you guessed it, there's that 90-degree angle. Our height has to make a 90-degree angle with base 1 and base 2. So again, we're looking for the 90-degree angle. They have to be perpendicular. It has to be that straight up and down to be the height. okay? And then you would plug your numbers in, make sure you follow order of operations, and you would get your answer. Your bases are the sides that are parallel to each other. So if I continued these two sides up, they would definitely cross, so those are not my bases. Where these two, if I continued them, they would never ever cross. So that's how you know what your base 1 and base 2 are. They are the sides that are parallel to each other. Okay, so for example, oops, let me draw that better. This is a trapezoid. Okay, in this case, the height is a side length because I do have 90 degrees. This is my base 1 and this is my base 2. So this is kind of like a trapezoid that's on its side. Because these are the sides that are parallel, they are the bases, and the height is what's 90 degrees to it. So again, don't always think bases are bottom or top. It's just the parallel sides. Now, the last thing we have to talk about with area. How to label area. Okay, so if I have a rectangle, okay, and this is 10 centimeters and this is 5 centimeters. Length times width tells me to take 10 times 5, 10 centimeters times 5 centimeters. 10 times 5 is 50. Centimeters times centimeters is centimeters squared. Okay, so we label area, all area is labeled square units. And by units, I mean centimeters, inches, feet, miles, yards. I don't care. It's square centimeters, square feet, square inches, square yards. Okay. Now, as you know, mathematicians hate writing, and so we'll use this little symbol to mean square. So I can say square units because that means to square something. So even though I put it after the word units, I would still read it square units. Also, this squared has nothing to do with a number. I am not squaring the number 50. I simply use that so I don't have to write that word out. And so that's how you will label all area all the time.